All right, today we're going to look at solving quadratic equations again. This is still section 3.1. Solving these quadratic equations in standard form. We have our quadratic term, the x squared term, the linear term, the x term, and the constant term. The term with no variable with it, it'll just be a number, constant, just a pure number. And we looked at how to solve it by graphing, looking for what we call the zeros, or the x-intercepts, same thing. Then we used the square root method, and that only works when b equals 0, so you would not have this middle term right in here. And then we could isolate the x squared, and we could square root both sides. And today we're going to talk about factoring as a method for solving quadratics. Now, the first thing we want to look at when we solve by factoring is why this works. And it works because what we call the zero product property. Zero product property is almost pure common sense. And basically, it just says if a times b equals 0, then a equals 0 or b equals 0. And so let's kind of look at this from a common sense point of view. Let's say 2 times x equals 0. What does x have to be? The only number x could be is 0, because the only thing you multiply 2 times to get a 0 is 0. And so if you had two numbers, a times b, and they equal 0, one of these, maybe both of them, but either a is 0, that's this part, or b is 0. One of them has to be true. And so we're going to exploit this to help us solve problems. We're going to start with easy ones. We aren't going to factor yet today, which gets kind of complicated. Instead, what we're going to do is just look at two binomials. I'll explain what I mean by that. Times x plus 2 equals 0. That zero product property says if I have two things multiplied together, and so I've got x minus 3 times x plus 2 equals 0, then one of those has to equal 0. And so I can write two separate equations. Either this has to be true, x minus 3 equals 0, or this has to be true, x plus 2 equals 0. One of these has to be 0 if the product, the multiplication of the two, come out to 0. And what it gives me now is two little linear equations. Add 3. I know what x is. X is 3. Subtract 2. X is negative 2. I've just solved that equation. Now, that does not look like a normal equation. Okay, we don't usually have equations written in this factored form. So I want to show you the original equation, where those two came from. So what I'm going to do is take my x minus 3x plus 2, and I'm going to multiply those together. Now to do this, we have to distribute. So we go x times x, and we go x times 2. Then negative 3 times x, and negative 3 times 2. These are like terms right here. So x squared minus x minus 6. So this quadratic equation is equivalent to this factored equation. Now, normally the way we're given quadratic equations is in this form right here, this standard form. ax squared plus bx plus c equals 0. But if we can get it to factored form, Then we can use this zero product property to figure out what x has to be. And so let me just show you now. If this was my original equation, I have its factored form up here, and it told me x could be 3, and that would make it true. So let's test it. Let's put a 3 in there for x. Oops, not sure what's going on there. There we are. That's 9 minus 3 minus 6, which is 6 minus 6, which is 0, which does make it true. Now I could do the same thing with negative 2. If I take negative 2 and substitute it in for x, I'd have the following: negative 2 squared minus negative 2 minus 6. Negative 2 squared is 4. Negative 2 is plus 2 minus 6. 6 minus 6 gives me 0. Again, it checks. So in general, what we get, we start with a quadratic that is in quadratic standard form. We have to get it to factored form. And then once it's in factored form, we set each factor equal to 0 because of the zero product property, and so solve those small equations. Now today's stuff is just practicing using the zero product property, and then we'll get to how we factor and how we work in this direction. But today we'll just start with this at the top. So let's take a quadratic that's already been factored for us. X plus 5 times x minus 3 equals 0. If a, this is like your a, times b equals 0, then either a equals 0, so either x plus 5 equals 0, or b equals 0, x minus 3 equals 0. Again, we always get two answers to these. Subtract the 5. There's one answer. Add the 3 in this case to get rid of it from the left-hand side. There's your other answer. Very simple. Let's take a look at something a little more complicated. 2x minus 4. Ooh, that's probably a bad example. Let me get rid of that. 2x minus 3, and then 5x plus 6 equals 0. This is like your a. This is like your b. And if the product of a times b equals 0, then either a equals 0 or b equals 0. Now you still have to solve these linear equations. It's just not always the opposite like you may have seen in the other ones. So in this case, I'd have to add 3 to both sides. And then divide by 2, yielding x equals 3 over 2. In the second option, subtract 6. 5x equals negative 6, and divide by 5. X equals negative 6 fifths. So there's our other solution. So those are our two answers. Now again, this is not normally how a problem starts. Usually this would all be combined into one big quadratic equation. But for right now, let's suffice it to say that it'll be given to you as a factored form. You just have to set each factor equal to 0 and solve those. Let's look at another example. Let's make this a little more complicated. Now this one's a little bit different. Notice this 6 out front here. You can divide by anything you want to except for an x, because x could be 0. We don't want to lose that. But you could divide by 6 at this point and get rid of that factor. And if I would divide this entire side by 6 and this side by 6, they would cancel, and it would just yield this. 0 divided by 6 is just 0 still. There's no 6's in a 0. And then I'm at, again, a times b equals 0. So either a equals 0, the 4x minus 5 equals 0, or b equals 0, the 2x plus 7. One of these has to be 0, otherwise the product would never equal 0. We'll just do a little math here, solving these nice little small linear equations. Divide by 4, that's one answer. 5/4. Subtract 7. And divide by 2. -7/2. That's our other answer. That's all there is to today's stuff. I'm going to give them to you in factored form. Set each factor equal to 0. Solve those little linear equations, and you will have your 2 solutions.